Hello, ladies and gentlemen. Today we'll be starting your Chapter 4 notes. You had your tests yesterday. Those are already in progress book. I will pass those back to you the next time I see you, which will be Friday. So I have posted 2 sets of notes for you. Okay, this is the notes for Wednesday, and then of course there'll be a homework assignment at the end of this. And then I have also posted a set of notes for Thursday, and there will be a homework assignment at the end of that. So then on Friday, obviously we are not having class, but if you are here, I'll pass back your homework and I'll pass back your test and I'll go over this homework for you. Okay, so lesson 4-3 is all about logarithms. Okay, logarithms are closely related to exponents, which is why we are going to start out recalling what the exponential function is. Now remember, with an exponential function, that means that the variable is in the exponent. So as you're looking at this function here, okay, you see that the variable, the x, is in the exponent. That b will be a base. It will be a number. Okay, so I'm going to ask you to find its inverse. Now remember, when we find an inverse, you flip-flop the x and the y. Okay, so notice I've done that. Okay, but then it's kind of like, now what? Remember, the whole point when finding the inverse is after you flip those x's and the y's, then you had to isolate for this y. Okay, well, how do I isolate that if I have a number that's the base in that b? So here's where we're going to introduce the logarithmic function. That is the logarithmic function. So it says y equals log base b of x. So again, you read that, log base b of x. Okay, there's some different parts to this thing. This part right here is the exponent. As I read, that part right there is the base. And then this is the answer. And that might not make quite much sense to you right now, but it will in just a second. So we have those 3 pieces there. This is logarithmic form. You see that log right in the equation. So with these pieces, then I can change this into exponential form. So I told you that the b was the base. So I want you to see that this b has now been moved down here as the base. I also told you the y was the exponent, which is there, and then this x is the answer. So you'll see I said equals x, and that's how you are converting from logarithmic form with an log in it to exponential form. Okay, so we're going to try that a couple times in our examples here today. So it says write in logarithmic form. Whoops, skipped ahead of me a little bit. Here we go, write in exponential form. So right now you can see that this has a log in it. I want to write it as just an exponential form. Remember, this is the base. Okay, we talked about just previously. Whatever it equals is the exponent. And then that number right in the middle there, remember, is the answer. So what kind of an equation can I write? I have base of 3, exponent of 2, and then the answer is 9. And folks, that is a true equation. 3 squared is 9. Okay, next over here, I have my base, I have my answer, and I have my exponent. So if I move all this around, I have a base of 10, an exponent of -3, and an answer of 1 over 1,000. Okay, and again, that is a true statement. If you recall, a negative exponent has to be moved to the bottom. So this will be 1 over 10 to the third. Well, then 10 to the third is 1,000. So you can see that that, in fact, is a true equation. All right, base of 6, we have our exponent of 0 and our answer of 1. Again, a true statement. 6 to the 0 power is 1. Now, number 4, you don't see a log, you see an ln, okay? ln is log with a natural base. And remember what the natural base is. The natural base is e. So really, we have that. But they abbreviate log with base e to be ln. So if I'm going to rewrite this in exponential form, I have a base of e, I have an exponent of 0, and an answer of 1. Again, a true equation. E to the 0 is 1. Finally, let's do an example where I really don't have any numbers. I've got my base of a, I've got my exponent of c, and I've got my answer of b. Okay, so we should be pretty good at changing from log form to exponent form. Let's go the other way now. I'm going to give you the exponent form, and I want you to turn it into log form. So I will have a log of base 2, because that is my base there. Remember that the answer goes next to the log, and then I have my exponent, which goes after the equal sign, which looks like that. Okay, so maybe I will write this up here for you. Log of base b of, I don't know, let's call it x equals y. So I just want you to remember your parts. This is your base, this is your exponent, and this is your answer. Okay, so let's look at number 2 now. My base, so this is log base 10. My answer goes next to that, and then my exponent goes off to the side. Now, something to note, you will typically never see log base 10. If there is no base, it is assumed that it is 10. Okay, so you do not have to write a log of base 10. Any other number, you got to write it in there. Okay, but they will typically not write that base of 10. All right, let's try number 3 here. I've got a log of base 1/8. The answer goes next, which is 64, and then the exponent goes off after the equal sign. I've got a log of base 10. My answer, oh, that's a big number, goes next to that, and then my exponent goes after the equal sign. Remember, we assume that it is base 10, so we are not actually going to write our answer with that base of 10 in there. And one more of these looks something like that. I've got a log of base a of b is equal to 7. Okay, folks, so that is transferring from logarithmic form to exponential form and exponential form to logarithmic form. You're just basically picking out the pieces and parts and putting them in the correct spot. Your homework for this is on your screen, okay, and we will go over that at a later date. Have a good day.